Part 2, Geometry, Pythagorean Theorem. Practice problem 11. Can you prove the Pythagorean theorem a squared plus b squared equals to c squared? So we can draw a simple right angle here. Say this short side is a, short side, another short side b, and the hypotenuse side, the long side, is called c. So can you prove that a squared plus b squared, the two short side square summing up equals to the square of the long side? Okay, this problem, we can make a square that you have a short side of A, short side of B. So this square has a side of A plus B, okay? And this inside, this side is C. And since this is a square, inside this is a square too. C square would be the area of the inside square. So outside square, you have a side of A plus B. Inside the square has a side C. So let's see. The total area of the outside is A plus B square. Okay, we can use different ways to decompose this square. A plus B multiply A plus B. Distributive properties. If we look at this second item as one thing, then you have A multiply A plus B multiply A plus B. Then we use distributive property again. A multiply A multiply B multiply A, B multiply B. Eventually, you would get A squared plus 2AB plus B squared, okay? And this triangle, these are all the same. We have 4 little triangles. What's the area for those? Triangle 1/2, the base multiply height, A multiply B, and we have 4 of these. Multiply 4, so it's 2AB. So if we have the total area minus the 4 little triangles, that would give you the inside area, the area for the square. The area for the square is c squared. C squared now equals to this minus this, A plus B squared minus 2AB. We already decomposed this, it's this. So now 2AB minus 2AB is going to cancel with this 2AB. Eventually you would get A squared plus B squared. 12. Find the length of the unknown side length in below graph. So this is a right angle triangle. 5, 12, you need to find the C. We already have the equation here. So 5 squared plus 12 squared equals to C squared. You calculate the sum of these two and find that which number of C would give you this summation. Or you look at this number, what is the perfect square number, and then you would find the C. We'll carry this one out. C, you can see that is 13. This example, we have 2 right angle triangle. You need to find the A. We have 26 and 24. You can find this side. Once you find this side, you have 6 squared plus A squared equals to this side square. Then you can find the A. So it's a 2-step process. So here for right angles, triangles, we want to remember there are 2 cases that we use the most. 5, 12, and 13, we use it a lot. And the other one would be 3, 4, 5. So for this case, 26 is 2 times of 13. 24 is 2 times of 12. You would know that this side would be 2 times of 5. That's 10. So that would be relatively easy. So again, then you look at the small triangle. This long side is twice the 5, and this short side is twice of the 3. So this one has to be 8. 13. we need to find the area of the shaded region. Shaded region is a square. So if we know, say this side is C, if we know C squared, then we would know the area of the shaded region. So let's start with this little triangle. 1 square plus 2 square equals to this side squared. And this side is already squared, plus this square would give you this side squared. And you just do it layer by layer. You know this side squared plus this side squared equals to this long side square. And then you continue on to get to finally this longest side squares. So let's work this out. The first length is 1 square plus 4 squares. That's 5. So then 5 plus 3 squares. And so this square would be 14. And then 14 plus 4 squares, that's 16. So this one would be 30. And so on. So 30 is already squared, plus 25. 5 squared, that's 25. So that would give you 25 plus 30, that's a 55. And then 55 plus 6 squares, that's 36. 55 plus 36, that's 91. So C squared is 91. Therefore, this area equals to 91. 14. If the length of a hypotenuse and another side of a right angle triangle is 145 and 17, what is the third side? Okay, the long side is called hypotenuse side is 145, and one short side is 17. What is this one? Okay, let's call this one A. So A squared equals to 145 squared minus 17 squared. So basically you have to carry these number out. This is going to be a very big number. Once you get a big number, you do prime factorization and you find out, for example, you have 2 to the power of 8 or 3 to the power of 4. Then you say, okay, if A squared equals to this, A must equals to 2 numbers multiplied together, right? So this same numbers. So we divide this exponent into 2. So one can have 2 to the power of 4. The other can have 3 to the power of 2. So you do prime factorization to get to this form, and then you separate each number into 2 shares, 2 same shares, and then that would give you, each one would equal to A to give you this A squared. 15. For a right angle triangle, the length of the 3 sides are all positive integers. One of the right angle edge is 7. Find the length of the hypotenuse, the long side. Okay, all positive integer. One of the right angle edge is 7. Find the length of this one. So now this, we have 2 sides that we do not know the length, right? So if we say this one is C, this one is A. We have C squared minus A squared equals to 7 squared. If students remember this, C squared minus A squared equals to C plus A multiply C minus A. If students remember this, we hope all students can carry this out, use this distributive property. C multiply the second one, A multiply the second one, then break up the brackets again, doing it twice. To get to the final answer, you will see this equals to C squared minus A squared. Okay, if we take this, C plus A multiply C minus A equals to 49. Therefore, C plus A and C minus A has to be factors of 49. What are the factors for 49? Factor of 1 or 49, both sides factors, and in the middle there's a 7, okay? So either C plus A equal to 49 and then c minus a equal to 1, or one of them has to equal to 7, but that's not going to work. So the bigger one has to equal to 49. The subtraction has to be equal to 1. C plus a equals to 49. C minus a equal to 1. These are two equations. We add both left sides up and the right sides up, so the equation doesn't change. Add them up, plus a minus a cancel. You get 2c equals to, add them up, 50. So C is now 25. So that's the question, answers the question for the problem. 16, the length of triangle ABC is 13, 14, 15. Find the area of ABC. The area of an ABC is the base multiplied height divided by 2. So we know the base, but we don't know the height. So we need to find what the height is. So height AD square equals to 15 square. There are two ways of calculating this, right? If you look at this triangle, right angle triangle, is the 15 square minus BD square. Or if you look at this triangle, it also, AD square also equals to 13 square minus CD square, this part. Also, BD plus CD equals to 14. So we have two relationships. One equation is here, one equation is here. I think it's easier that we have an unknown for this. So BD, we call that A. CD, we call that B. So now we have 15 minus A squared equals to 15 square, CD squared, that is B squared. And this is A plus B equals to 14. For this equation, we can change that into A squared minus, we move A squared to this side, minus B squared equals to, move 13 squared to this side, 15 squared minus 13 squared. And the student can figure this one out. And again, A plus B, A squared minus B squared is A plus B multiply A minus B equals to this number. This number, if you calculate, is 56, okay? Now, A plus B, you know already, is 14, right? So this would give you A minus B equals to 56 divided by 14, which is 4. So you have A plus B equals 14, A minus B equals to 4. Same equation as you see here. Add both left sides up, add both right sides up. 2A equals to 18. Now A is 9. Okay, once you know A, B is just 5. So now you know both A and B. You can use either one to find out AD. Now you find the area for the triangle.